Hi, everyone, and welcome to the Winter Forecast 2025-2026. My name's Ethan Sakaransky. I'm a diagnostic radiology resident at the University of Saskatchewan in Saskatoon, Canada. And I previously completed my medical training in Queen's University, Kingston, Ontario last year. And prior to that, I worked as a meteorologist at the Weather Network in Oakville, Ontario, Canada. For me, this is a very exciting time of year because we're getting closer to the winter. And for anyone interested in weather and climate, this is the time where start to look at some of the different drivers of the climate. And as I see it this year, there's really four major drivers that are going to be affecting the winter. The first is El Nino Southern Oscillation, so whether or not we see a La Nina or an ENSO neutral state. Second being what is going on in the North Pacific. We're already seeing a marine heat wave developing over the North Pacific, and that's likely going to have impacts on the winter. Third is the quasi-biennial oscillation, which I'll explain a little bit more later and how it can affect the winter. And then the fourth, which is a bit of a wild card this year, is the state of the Indian Ocean dipole. First of all, starting with La Nina, we can see that as of a few days ago, the weekly anomalies are ranging anywhere from minus zero point 0.2 to minus 0.5, which is essentially borderline getting into weak La Nina territory, but still in the cool neutral phase at the moment. Looking at the current broad sea surface temperature anomalies across the globe, we can see the beginning of a La Nina signature coming off the west coast of South America and the equatorial Pacific, with very warm sea surface temperature anomalies across the North Pacific. And this La Nina event, it's just beginning to form. It's still not at its peak yet, but we have seen it beginning to strengthen in October and September, and it's expected to continue to strengthen throughout the fall season. And zooming in a little bit to the La Nina region, we can start to see those cooler waters off the coast of Ecuador and Peru. Most of the area is just weakly below normal, but there's some eddies that start to form minus twos into minus threes even, and that's an indicator that the event is beginning to strengthen. And from the Climate Prediction Center, they issued a La Nina watch on September the 11th, and they say that a transition from ENSO neutral to La Nina is likely in the next couple of months, with the 71% chance of La Nina during October to December of 2025. And then thereafter, they forecast some weakening as we head into December to February, midwinter period. If we look at the International Research Institute, the IRI ENSO Plume forecast, what they're showing is a conglomerate of all the various forecast models from different countries across the globe. And looking at it basically splits the models into dynamic models and statistical models, which are just different type of climate models. Looking at the dynamical models, the anomalies that are expected as we head into fall and early winter is around minus 0.6 to minus 0.7 for about 3 months, which would meet the threshold for a La Nina event. Whereas on the statistical models, they're hovering right around 0.5, which is borderline for La Nina versus borderline ENSO neutral. So depending on which models you believe, it can vary. I tend to believe that it's going to be closer to the dynamical models, which is probably a weak to borderline moderate La Nina expected. And I would say that my forecast aligns well with the NMME, the North American Multi-Model Ensemble, which is essentially a grouping of models from Canada, the United States, and Mexico. And if you plot every one of the models and you look at the average of all the models, the NMME is the strongest of the major global models in forecasting this La Nina. Not too strong of an event, still anywhere between minus 0.5 and minus 1, which is in the moderate range. weak to moderate, and I think that's probably what we're likely to see this year. And the European model, which is another important global model, it's more in line with the IRI, showing a weak La Nina event. And then looking at the zonal wind anomalies and the low levels of the atmosphere across the equatorial regions, we can see that in the month of October and September, here in blue and purple, this indicates that an easterly wind burst that moved across the equatorial Pacific. And then you can see again here in September, and then we actually seeing it again now in middle of September. So that's kind of 3 bursts of easterly winds that have moved across the Pacific that have helped to intensify the La Nina conditions that we're observing. Keep in mind that just a few months ago, it was looking a lot more likely that it was going to be a neutral event and not even a La Nina, but because we've been seeing it trending a little bit stronger with the easterly winds setting in, we're seeing changes in the climate modeling forecasts. But if we look at what's going to be happening in the future, so below this black line here, the easterly wind anomalies don't look very organized for the rest of September into the first half of October, which leads me to believe that probably the event is going to level off for a few weeks, and then we'll probably see it strengthen again late October, mid to late October through November. And most of the reasoning for this, if we look at the MJO, so the rising or sinking motion occurring over the equator. In green here, this is all rising air, essentially. And we can see all of this rising air in August and September that's been concentrated essentially over the eastern Indian Ocean and into Indonesia, Southeast Asia, which we would call the maritime continent. And when you have most of the upward motion over the maritime continent, you set up the winds, the low-level winds in the atmosphere to be in a favorable position for La Nina to strengthen. And when these winds start to break up, so if we look at the forecast here, there's not as much upward motion. It's not very organized over the eastern Indian Ocean like we saw in August and September. And because of that, the easterly winds are supposed to weaken. They're forecast to weaken in the equatorial Pacific. So we probably will see a slowdown in the La Nina. And there might be some discussion on, is it really going to be a La Nina? But I do suspect that we'll see the MJO again becoming established over Indonesia as we get further into October and then into November. So for the second variable that I've been looking at, it's the North Pacific. And as I mentioned before, we see that there's a marine heat wave that is actually in place already across the North Pacific. And it actually spans a really large area all the way from Japan and South Korea all the way over here to all the way across the North Pacific, going all the way even towards the coast of California and the BC coast as well. And there's a couple of hypotheses on what might be causing this. One is it could be the Kuroshio current, which is an underwater current that we basically see in this region here that pumps warm water from the tropics up towards east of Japan. And the Kuroshio current, if it's strengthening, if it's in a very strong phase, it can cause this warming that we're seeing in the sea surface temperatures across the North Pacific. So that could be what is driving the marine heat wave. And another possibility, or it could be the two combined together, but another driver would be what we're seeing in the atmosphere. So if we look at the upper level height anomalies across the North Pacific, we can see that between April and August of this year, there was a lot of high pressure ridging across the North Pacific. And that type of pattern is favorable for warming of those sea surface temperatures across the North Pacific. Taking a look at the anomalies that we saw, this is a 4-month average, and much of those sea surface temperatures are 2 to 4 degrees above normal, which is near the maximum probably of the climate envelope. If we look at all the sea surface temperature anomaly data, probably over the past century, this event would, based on my analysis, would probably be in the top, for sure in the top 5%. It could be in the top 1% of warm anomalies that we would see across this region, which is very, very significant. And if we look at the impacts from a jet stream perspective, basically at the jet stream level, we can see, according to these anomalies that we've seen across the summer, the jet has been displaced further to the north and it's stronger than normal. Now, if we have stronger than normal for winter, that can oftentimes flood North America with mild Pacific air, which would portend to a warm winter, very warm winter. But further north Pacific jet and strong, which we saw in a year like 2013-14, sets up a lot of blocking across the Aleutian Islands and into Alaska, which can actually cause a very cold winter. So how this pattern is going to translate into winter as the jet stream strengthens and changes its configuration, that remains to be seen. And obviously that's going to have an impact on the forecast. Looking at what we saw that year in 2013-14, there was a lot of similarities to what we're seeing right now in the North Pacific, which with a big warm blob across the Northeast Pacific Gulf of Alaska. And also sort of a weak La Nina event, borderline cold neutral that year as well. So, in my opinion, with the similarities to that year, what I think 2013-14 represents is kind of the extreme of what we could see with respect to cold this winter. That winter was frigid across the Great Lakes region and into the interior Northeast and Midwest. It was one of the snowiest winter on record for Detroit, from what I remember, and had a very significant ice storm across Michigan and into southern Ontario during Christmas time. That was very memorable, in addition to pretty much a relentless Arctic air that came south into the eastern United States with very strong high pressure across the Aleutian Islands, Alaska, and the Bering Sea. So that to me represents the extreme of what could happen this winter. Is it likely to happen? No, I don't think it's likely, because just statistically speaking, for that strength of an Aleutian block to develop and to be sustained for so long throughout the winter season just doesn't happen very often. So I don't expect that to happen. But we could see periods that come up in the winter where we do see significant blocking in the North Pacific, which could result in significant blasts of Arctic air into North America. So that's definitely something to look out for. So taking a look now at the third variable, which is the QBO, or the quasi-biennial oscillation. So that, the naming, basically quasi meaning like sort of, biennial, every 2-year oscillation. So pretty much with the QBO, it's a climate oscillation where the period of the oscillation is about 2 years. So if you take the state of the oscillation right now and then you look at where it would be in 2 years from now, plus or minus a few months, you would be at the similar phase as you would be 2 years prior to that. So the period, like we would say in physics, is about 2 years for this oscillation. So what that means is that it's always oscillating. What is the QBO? It's an area of zonal winds. So it's essentially a wind oscillation that you see in the stratosphere that circles over the equator of the globe. So if you measure the winds in the stratosphere over the equator, in this slide, it's at Singapore, which is why it's an equatorial location. And what scientists have discovered is that if you look at any location over the equator, whether it's Singapore or another location where you can put a weather balloon into the atmosphere and measure the winds in the stratosphere, it would give you similar result. So in other words, if you changed your longitude, the state of the QBO will be similar, no matter where you are over the equator. So we can use Singapore as basically a proxy for the QBO state across the entire equator. And so with this oscillation, it's always oscillating back and forth, easterly, westerly, easterly, westerly. Usually, as I said, it takes about a year to a year and a half for it to switch from east to west. And for this year, we're in a strong easterly phase. So if we look at this graph, it's showing that the zonal winds so if we look at 30 millibars, which is mid-stratosphere, the zonal wind anomaly is somewhere between minus 25 and minus 50. So say minus 30 to minus 40. And then another key important height that we look at is the 50 millibar level. And we can see the data point there is negative, probably around minus 10. And the state that we're in right now is that this pattern is moving down in the stratosphere. So the peak here of the easterly winds are going to be, as we get into the middle part of the winter, are probably going to be peaking between 30 and 50 millibars, which is right in the heart of where we care about this oscillation, which means that the impacts of this QBO easterly phase will be strong this winter, stronger than we see in most years, because in a lot of years, we'll kind of be in the shoulder of the QBO where it's not at its peak intensity. It'll be either weakening or just starting to strengthen. But this year, we're seeing an easterly phase near the peak, which tells me that there's going to be impacts from that on the polar vortex for the winter forecast. And then this is just another way that you can look at the Singapore winds as a time series going from 2023 till present. And we can see this year the these easterly winds that are descending down the stratosphere and now getting into the middle and lower stratosphere here. And that's going to continue to happen as we head into winter. So Holton and Tan, they published a really well-known and important paper in 1980 that first proposed a mechanism explaining how the QBO influences the northern hemisphere stratospheric polar vortex. And they called this the Holton and Tan effect. And their hypothesis suggested that basically when you're in an easterly QBO phase, you get a weaker polar vortex, or what you would call a warmer vortex. And in the westerly phase, you get a stronger polar vortex. So when you have a weaker polar vortex, like we may see this year because we're in the easterly phase, that has more of a tendency for you to see stratospheric warming event, which can allow cold Arctic air to move south into the mid-latitudes. And so what's really key about their study is that they showed that there's a link between this QBO, which is a very abstract wind oscillation over the equator, and impacts on the poles. So there's a connection between the equator and the polar latitudes in terms of their relationship to each other and how they affect the climate. And they also show, so as I mentioned before, when you're in the easterly phase, more likely to see a negative Arctic oscillation and more frequent cold air outbreaks into North America and Eurasia. And I was looking at a recent paper by Kumar et al. From last year that looked at the relationship between the QBO and ENSO phases. And according to their analysis, in La Nina years, essentially the HT, the Holton tan effect, was amplified, which means that in La Nina year with an easterly QBO, there was more likely to be blocking over the pole, high pressure over the pole, and more stratospheric warming events. Whereas in westerly QBO events with a La Nina, these were less likely to occur. And on this plot here, this is an example of a westerly QBO event. And in green, you can see all the low heights or low pressure indicated across the poles from 60 to 80 degrees north latitude. And then you would switch that. It would be the opposite in the easterly phase. In the easterly phase here, you get all that blocking over the pole. And that confirmed previous findings, which essentially other papers have shown that the Holton and tan mechanism can be amplified during a La Nina year. And what that might mean for this winter, which is a La Nina year with easterly QBO, that blocking could be more likely across the pole and maybe more likely to see some sort of a stratospheric warming event. However, what was also interesting about this paper is that that relationship didn't hold in neutral ENSO years. So what this plot is showing is G1 is west, G2 is east. If you subtract them, it shows that in the westerly QBO events, you had a lot of blocking over Alaska and into the pole, and cold air coming into North America. Whereas in the easterly phases, warm air across North America with less blocking. So what that shows that in the neutral years, you didn't have that relationship hold. So how do we relate that to the winter? What it basically, just based on this paper, what it could say is that if we're more along the ENSO neutral, a weaker La Nina, maybe less likely to see blocking. Whereas if it's more established La Nina, weak to moderate La Nina, we may be more likely to see blocking given the easterly state of the QBO that's in place. But it's just based on one paper, but it's something interesting to think about. And then lastly, they're just talking about the different connection, and they're saying that in the neutral years, it's a different mechanism of this HT mechanism, and it's via a subtropical jet. And I did do an analog analysis. I looked at all years since 1979, classifying La Nina as December, January, February, oceanic Niño index less than or equal to minus 0.5, and I split east-west QBO at 30 millibars, defined as zonal winds less than 0 or greater than 0. So since 1979, on the left plot is the west QBO La Nina, and on the right plot is the east QBO La Nina. Both sets of years, which is common in La Nina, we can see the ridging over the Northeast Pacific into southern Alaska. But the main difference between QBO east and west, in my analysis, was over the North Atlantic Oscillation region, or over Greenland, where in the west years we see a lot of blocking over Greenland, and then in the east years more of a positive NAO, so not as much blocking. So that would suggest that in a year like this year, we may tend towards more of a neutral to positive North Atlantic oscillation, not as much blocking over Greenland, and for the dominant blocking to be over the Northeast Pacific, Alaska, and perhaps into the Bering Sea and the Aleutians. That's going to be the area to watch for more blocking. And then the Hudson Bay vortex, polar vortex location, is also something that could be a feature of this year's pattern. Lastly, before I wrap it up, Indian Ocean dipole, that's another wild card for this winter. This plot shows an example of the pattern that we'd see in a positive phase of the Indian Ocean dipole, which demonstrates warm sea surface temperatures in the Western Indian Ocean and cool sea surface temperatures in the Eastern Indian Ocean towards Indonesia. And then this year, we're actually seeing the opposite pattern, where we have cool sea surface temperatures across the Western Indian Ocean and the warmth in the Eastern Indian Ocean towards Indonesia. And the reason that I think that this could be a wild card for the winter is that if we look at a time series of the Indian Ocean dipole over the last several years, the data, the values that we're seeing now this September are the coldest that we've seen since September, October of 2022, which tells me that this is a fairly significant negative IOD event, and it will likely have impacts on the greater climate and winter forecast ahead, given the fact that the Indian Ocean, it's a large ocean basin, it's a large source of heat, a large source of potential energy that can impact the Madden-Julian oscillation convection that occurs over the tropics, which does impact the jet stream across the North Pacific and the Northern Hemisphere as a whole. And looking back at even further towards 2009, 2008, there's only been 3 other events that are similar to this negative IOD event. One is 2010, the fall of 2010, fall of 2016, and as I mentioned before, the fall of 2022. Similar in magnitude and pattern to this year. And so what that tells me is that this likely, it's an anomalous event. It will likely have an impact on the winter forecast. And it's a bit of a wild card for me personally, because I personally haven't done a lot of research on how that, coupled with the La Nina or coupled with the East QBO and the other variables we look at for the North Pacific, how that is going to come into play and affect the pattern across North America. So that's something definitely to keep in mind. So for my analog years that I'm looking at that are most similar to this winter, in my opinion, based mostly off of sea surface temperatures and looking at QBO phase as well, and the temperatures that we're seeing both in the North Pacific with the marine heat wave and the La Nina, the weak to moderate La Nina. The years that I thought were most similar were 2013-14, 2017-18, 2020-21, 21-22, 22-23, and 24-25. And then, so this is what the sea surface temperatures look like, the blend of all of those years, which is pretty similar to what we see this year. If we look at the upper level pattern, we can see significant ridging across the Arctic Circle, Northeast Pacific and into Alaska, with a pretty strong trough centered across Western Hudson Bay and into Northern Ontario and Manitoba, with some ridging favored across the southern United States and into the southeastern United States. And how this impacts the surface temperatures, as we can see on this analog forecast, the core of the cold is focused across the eastern prairies, Saskatchewan, Manitoba, Ontario, northern plain states, into the western Great Lakes region, and even a signal for some cold air outbreaks coming down into Texas, below normal temperatures through Texas and the plain states. Relatively equal chances of below and above normal across the Ohio Valley and into the eastern Great Lakes, southern Ontario region, St. Lawrence Valley, with above normal temperatures favored across Atlantic Canada, southeastern United States, and the southwestern United States, Arizona through California. Relatively equal chances of below and above normal across the Pacific Northwest and into BC. And then I-95 corridor, East Coast, slightly above normal temperatures favored, near normal. New England, slightly above normal temperatures favored. And so this is just an estimate. I could see this trending a little bit colder potentially, but I think this is pretty good middle ground forecast that we would be looking at. And lastly, in terms of precipitation anomalies, what would be the pattern to be favored would be dry anomalies across the U.S. Southwest into California and Texas, with below normal snowfall. Also drier than normal across the Southeast, Florida, the Carolinas, and into the Mid-Atlantic states. Near normal precipitation across the I-95 corridor, and then potentially a corridor of above normal snowfall from the Ohio Valley into southern Ontario and southern Quebec, Montreal, Quebec City was what I'm thinking. Atlantic Canada above normal precipitation, but if temperatures are above normal, may not be above normal snowfall. And then across the Canadian prairies, above normal snowfall is likely with the La Nina slightly above normal into northern Ontario as well. Along the BC coast, drier a little bit. Southern BC with most of the precipitation concentrated towards northern coast of BC and through Alaska. But I'd emphasize with the precipitation forecasting can be very difficult, so take it with a grain of salt. So that's it for my winter forecast. Thank you so much for tuning in. Basically, to sum up, there's a lot of moving parts. It's a difficult forecast, but overall, these are the thoughts that I'm thinking. These are the variables I'm looking at that I think are most important, and we will see how things go. So thank you so much for tuning in, and bye-bye for now.